Are you about to build your very first electronics project? That's exciting. But soon you'll face a crucial decision: which microcontroller should you use? With so many options like Arduino ESP32, STM32, and PIC, it's easy to feel overwhelmed. But don't worry, this video is here to help. We'll break down the process into a simple, beginner-friendly guide. By the end, you'll know exactly how to choose the right microcontroller for your project, no matter your experience level. Let's dive in and make your electronics journey smooth and successful. First steps to clearly define your project. Ask yourself, what do I want to build? Is it a simple LED blinker, a smart doorbell, a robot car, or maybe a temperature logger? Think about what your project needs to do. Do you need to connect sensors, control motors, or communicate over Wi-Fi or Bluetooth? Jot down your ideas and requirements. Having a clear project goal will guide every decision you make from here on out. Remember, clarity at this stage saves time and confusion later. Next, count your inputs and outputs. These are your I/O pins. Every button, sensor, LED, or motor you use will need a pin on your microcontroller. For example, a simple LED blink project might only need one digital pin, while a robot car could require several pins for motors, sensors, and more. Look at your project plan and make a list of all the connections you'll need. This step helps you avoid running out of pins halfway through your build. It's a small detail that makes a big difference. Now consider your connectivity needs. Does your project need to connect to Wi-Fi, Bluetooth, or maybe even cellular networks? For example, a weather station that uploads data online will need Wi-Fi. A smart doorbell might use Bluetooth to talk to your phone. Make a note of any wireless or wired communication your project requires. This will help you narrow down your microcontroller choices, since not all boards support every type of connection. Processing power matters, especially if your project does more than just blink an LED. Ask yourself, does your project need to process lots of data, handle graphics, or run complex algorithms? For simple tasks, an 8-bit microcontroller like Arduino Uno is often enough. But for more demanding projects like image processing or real-time control, consider a 32-bit board like the ESP32 or STM32. Always match your microcontroller's capabilities to your project's needs. Memory is another key factor. Microcontrollers have two main types of memory: RAM for running programs and flash for storing code. If your project uses large libraries, handles lots of data, or needs to store files, you'll need more memory. For basic projects, small memory is fine, but for advanced applications, check the specs carefully. Running out of memory can cause frustrating bugs and crashes, so plan ahead. Let's talk about budget. Microcontrollers come in a wide range of prices. Some, like the Arduino Uno, are affordable and great for beginners. Others, like the STM32, offer more features but can cost more. Decide how much you're willing to spend. Remember to factor in the cost of accessories, sensors, and modules. Sometimes spending a little more upfront saves money and headaches down the road. Let's look at some popular microcontroller options. The Arduino Uno is a classic choice for beginners, easy to use and well documented. The ESP32 is perfect for projects needing Wi-Fi or Bluetooth, and it's affordable too. STM32 boards offer lots of power and flexibility for advanced users. PIC microcontrollers are reliable and used in many commercial products. Each has its strengths, so choose based on your project's need. Arduino Uno is one of the most popular microcontrollers for beginners. It's easy to program, has plenty of tutorials, and a huge community for support. With 14 digital I/O pins and 6 analog inputs, it's perfect for simple projects like LED blinkers, temperature loggers, or basic robots. If you're just starting out, the Arduino Uno is a safe and reliable choice. The ESP32 is a powerful microcontroller with built-in Wi-Fi and Bluetooth. It's perfect for connected projects like smart home devices, weather stations, or IoT gadgets. The ESP32 has more processing power and memory than the Arduino Uno, making it suitable for more complex applications. If your project needs wireless communication, the ESP32 is a fantastic choice. STM32 microcontrollers are known for their high performance and flexibility. They come in many versions from basic to advanced, and are used in everything from hobby projects to professional products. STM32 boards are great for projects that need lots of processing power, real-time control, or advanced features. If you're ready to explore more complex electronics, STM32 is worth considering. PIC microcontrollers are reliable and widely used in industry. They're available in many sizes and capabilities, making them suitable for everything from simple gadgets to complex systems. PICs are a bit less beginner-friendly than Arduino, but they're a solid choice if you want to learn about professional-grade microcontrollers. See a real project example, the classic LED blink. This is often the first project for beginners. All you need is a microcontroller, an LED, and a resistor. You connect the LED to a digital pin, write a simple program, and watch it blink. This project helps you learn the basics of programming and hardware connections, and it works on almost any microcontroller. Another great beginner project is a weather station. This uses sensors to measure temperature, humidity, and maybe even air pressure. With a microcontroller like the ESP32, you can upload data to the internet or display it on a screen. This project introduces you to sensors, data collection, and wireless communication, all key skills for electronics makers. Robot car is a fun and challenging project. It usually needs several I/O pins for motors, sensors, and maybe even wireless control. You'll learn about motor drivers, obstacle detection, and basic robotics. This project is perfect for exploring more advanced microcontroller features and expanding your skills. Smart doorbell project combines sensors, wireless communication, and user interaction. You might use a button, a camera, and Wi-Fi to send notifications to your phone. This project teaches you about integrating hardware and software, and it's a great way to see the power of microcontrollers in real life. Before you buy your microcontroller, run through a quick checklist. Does it have enough I/O pins? Does it support the connections you need? Is there enough memory and processing power? Is it within your budget? Are there tutorials and community support available? Answering these questions will help you avoid surprises and make your project smoother. It's helpful to compare popular microcontrollers side by side. Create a simple table listing features like pin count, memory, connectivity, and price. This visual comparison makes it easier to spot the best fit for your project. Sometimes, seeing everything at a glance helps you make a confident choice. Don't underestimate the value of community support. Some microcontrollers, like Arduino, have huge online communities with tons of tutorials, forums, and example projects. This makes troubleshooting and learning much easier. If you're a beginner, choosing a board with lots of support can save you time and frustration. Check what programming language your microcontroller uses. Arduino uses a simplified version of C++, while ESP32 and STM32 can use C, C++, or MicroPython. Pick a board that matches your comfort level or one you're excited to learn. The right language can make your project more enjoyable and less intimidating. Consider the development tools and software you'll use. Arduino has its own easy-to-use IDE, while ESP32 and STM32 might use more advanced tools. Some boards support drag-and-drop programming or visual interfaces. Make sure you're comfortable with the tools available, as this can affect how quickly you get started. Think about future expansion. Will you want to add more sensors, motors, or features later? Some microcontrollers have shields or modules that make adding new hardware easy. Planning for expansion now can save you from having to switch boards later on. Don't forget about power. Some projects run on batteries, others plug into the wall. Make sure your microcontroller can handle your power source. Check voltage and current requirements and consider power-saving features if your project needs to run for a long time without charging. Physical size can be important, especially for compact projects. Some microcontrollers are large while others are tiny and fit into tight spaces. Measure your project enclosure and make sure the board will fit comfortably. Don't forget to allow space for wires and connectors. Check the availability of your chosen microcontroller. Some boards are easy to find everywhere, while others might be out of stock or hard to source. Make sure you can get the board and any accessories you need before you start your project. Good documentation makes a huge difference. Look for boards with clear datasheets, user guides, and example projects. Well-documented microcontrollers are much easier to learn and troubleshoot, especially for beginners. Some microcontrollers are easier to learn than others. Arduino is famous for its beginner-friendly approach, while STM32 and PIC might require more advanced knowledge. Choose a board that matches your current skill level or one that challenges you just enough to keep things interesting. How much time do you have for your project? Some microcontrollers are quicker to set up and program, while others take more time to learn. If you're on a tight deadline, pick a board with lots of ready-made libraries and examples. This can help you finish your project faster and with less stress. Debugging is part of every electronics project. Some microcontrollers have built-in debugging tools or support for external debuggers. These features can make finding and fixing problems much easier, especially as your projects get more complex. Safety is important, especially when working with higher voltages or motors. Some microcontrollers have built-in protection features like overcurrent or thermal shutdown. Always check the safety specs and never skip safety precautions in your projects. Some microcontrollers are open source, meaning you can freely use and modify their hardware and software. Others are proprietary, with restrictions on use or modification. Open source boards like Arduino are great for learning and sharing, while proprietary boards might offer unique features or support. A strong ecosystem means more accessories, shields, and modules are available for your microcontroller. Arduino, for example, has a huge range of add-ons. This makes it easier to expand your project or try new ideas without starting from scratch. Consider how long your microcontroller will be supported. Some boards are updated regularly while others may be discontinued. Long-term support means you'll get bug fixes, new features, and help from the community for years to come. If you care about sustainability, check if your microcontroller or its manufacturer follows eco-friendly practices. Some companies use recycled materials or energy-efficient manufacturing. Making responsible choices helps the environment and sets a good example for others. Firmware updates can add new features or fix bugs in your microcontroller. Check how easy it is to update your board and whether updates are released regularly. Staying up to date keeps your project running smoothly and securely. Security is especially important for connected projects. Some microcontrollers offer built-in encryption, secure boot, or other safety features. If your project connects to the internet, make sure your board can protect your data and privacy. Explore what others have built with your chosen microcontroller. Community projects can inspire you, provide code examples, and help you learn faster. Seeing real-world uses is a great way to spark new ideas and avoid common mistakes. Every project hits a snag at some point. Learn basic troubleshooting tips, double-check your wiring, read error messages, and use online forums for help. Patience and persistence are key. Don't give up if things don't work right away. As you gain experience, you might want to upgrade to more advanced microcontrollers. Start simple, then move up to boards with more features as your skills grow. This step-by-step approach helps you build confidence and avoid frustration. Don't forget to celebrate your progress. Completing your first project is a big achievement. Take time to enjoy your success, share your results with friends or online communities, and start thinking about your next build. Let's recap the key points. Define your project, count your I/O pins, check connectivity, consider processing power and memory, set your budget, and look for community support. These steps will help you choose the right microcontroller and set you up for success. Ready to get started? Pick a project idea, choose your microcontroller, and gather your parts. Remember, learning electronics is a journey. Take it one step at a time and don't be afraid to experiment. The more you build, the more you'll learn. There are tons of resources available for beginners. Check out online tutorials, forums, and video guides. Many microcontroller manufacturers offer free documentation and example projects. Use these tools to speed up your learning and solve problems as they come up. Curiosity is your best tool. Keep exploring new ideas, trying different microcontrollers, and building creative projects. Every mistake is a learning opportunity, and every success brings you closer to mastering electronics. You've got this. Choosing your first microcontroller might seem daunting, but with this guide, you're ready to make a smart choice. Remember, every expert started as a beginner. Stay positive, keep building, and enjoy your electronics journey.